Tutorial question number 5. In an experiment, 2 grams of benzene were burned in one calorimeter. Temperature change is 9.62 degrees Celsius. If the heat of combustion of benzene is released 3,268 kilojoule per mole, calculate the heat capacity of the burned calorimeter. So again, from here, we know that heat of combustion is delta H. So this question needs us to look for the heat capacity, which is a capital C. So if you still remember in the previous slide, we did mention for answer this question, step 1, we need to look for the heat release. Second, we find the number of mole. So because this is combustion of benzene, means that we need to look for the number of mole of benzene. So formula for benzene is C6 H6. So step yang ketiga, then only we look for the delta H. Okay, so but then when we look at this question, heat capacity will be found, will be appear in the working step of the step 1, right? So means that in this question, we have to do daripada step 3 kepada step 1. Okay, so step 3 already let us know this is the delta H is 3,268 kilojoule per mole. But then we need to do step 2 lah. Okay, so we need to find out more of the benzene. So given the mass is 2 grams over the molar mass of the benzene is 78, so it will equal to 0.02564 mole. Then now we know that if 1 mole of benzene is burned, it will release it will release 3,268 kilojoule. But in this question here now, we only burn 0.02564 mole. So that's why by using the crossover multiplication, so you will notice that this is 83.79 kilojoule, which basically is referred to Q. Okay, this 3,268 is referred to delta H because it is in 1 mole. Okay, so when the heat energy is not in 1 mole, we will consider it as Q. Okay, so now then we can proceed to look for the Q. So as we know, Q is equal to heat absorbed by calorimeter, water or solution. So again, when we read this question, we only have the information about calorimeter. So that means we are going to heat release is equal to heat absorbed by calorimeter. Heat absorbed by calorimeter. So information about calorimeter in this case is heat capacity, which is capital C. So we will come with the formula with the delta T. Okay, so then from here, when you then you need to substitute the value in here. But then we no need to consider the negative sign is okay with 83.79 kilojoule. So basically you need to convert if you can maintain in kilojoule per mole equal to C delta T. So C is question mark, delta T given is 9.62 degrees Celsius. So when you do the calculation, basically we just need to consider 83.79 because the negative sign over here just want to show heat release. Okay, so just press the calculator. C will equal to 87.79 kilojoule over 9.62 degrees Celsius, and then you press the calculator, you will get 8.71 kilojoule per degree Celsius. After discuss 3 questions about the enthalpy of combustion. So question number 6 now are related with the enthalpy of neutralization. So a student carry out an experiment in a coffee cup calorimeter to determine the enthalpy of neutralization between HBr and KOH. So these are the information, volume, temperature, and also the specific heat capacity of the solution. Question A, based on the experimental data above, calculate the number of mole of water produced. So how many mole of the water produced will depends on how many mole of the reactant are used in this experiment. So now let's calculate the number of mole for the HBr. So because they are solution, so when we want to find the number of mole for the solution, normally we're going to use the formula mv over 1000. So when we check the concentration for both HBr and KOH are similar, the volume also similar, so we can just simplify, mention that number of mole of HBr will equal to number of mole of the KOH, so it will equal to mv over 1000. So the m is 2, the volume is 50, and also divide by 1000, so it will be equal to 0.1 mole. Okay, then this is the first step. So step 2, we're going to write the chemical equation. So HBr equals plus KOH equals will produce KBr equals and H2O. And then this equation is balanced. So based on here, we notice that the ratio to is 1 HBr, 1 mole KOH, and then we'll produce 1 mole of H2O. Since the number of mole of KOH and HBr are similar, which is 0.1, so both of them will be completely used up because the ratio here is 1 to 1. Both completely reacted. Okay, and therefore number of mole of H2O will equal to number of mole of HBr and also number of mole of KOH, which is 0.1 mole. Okay, proceed to question B. Enthalpy of neutralization means that we need to calculate the delta H. So in this calorimetry, we have 3 steps. Step 1, we need to determine the Q. Step 2, we need to determine the number of mole. So in this case, because it's neutralization, based on the definition, is when 1 mole water is formed. So that's why you need to find the number of mole of water, which we already determined in part A is 0.1 mole. So we write it down first. So then next step number 3, only we can determine the delta H. So before we can get the delta H, means that now we have to settle for the Q. So for the Q here, step 1, heat release. I put the negative sign to show that the heat is released, will equal to heat absorbed by calorimeter. However, when we go through the information here, we have no idea about calorimeter. So that's why we are not going to use calorimeter. And then when we go through the information here, we have HBr, KOH, HBr, KOH solution, and solution we also doesn't have information about water. So the heat release will not absorb by the water, but it will be absorbed by the solution. Okay, because we have the solution over here. Okay, so when we have the solution over here, then the next step we will decide. We need to use C delta T or MC delta T. Because of the specific heat capacity is given, which is referred to small c, so means that we are going to use the MC delta T, MC delta T. So and then because this one is the specific heat capacity of solution, therefore the mass over here have to refer to mass of solution. So the solution basically is 50 ml KOH and another 50 ml HBr. So that's why we will use 50 plus 50. C given here is 4.2. So we just substitute in 4.2. And then delta T is the change of the temperature. The final temperature is 35 degrees Celsius, and then we need to minus the initial temperature. But when we look at here, the initial temperature for HBr and KOH are different. So that's why for this, we need to get the average initial temperature, which is 21.2 plus 21.6 divided by 2. Before we further on, maybe some of you will ask, here is milliliter, but this one mass supposedly is in the gram. Why we can add on directly like this? Maybe you can remark yourself. In this case, basically we need to do the assumption that the density of solution is equal to density of water. So which is equal to 1 gram per ml. So that is why when we have 100 ml solution, it will be also equal to 100 gram. So this one is in the unit of gram, and then this one is joule per gram per degree Celsius, and this one is in the unit of degree Celsius. So degree Celsius and per degree Celsius can be cancelled out. Per gram and gram can be cancelled out. When you press the calculator, you will get 5712. So now only left the unit of joule. So step 1, the answer is 5712 joule. Don't forget, because you already put the negative sign over here. If you don't want to put the negative sign at the left hand side, then you can write down Q equal to negative 5712 joule. So we already settled for step 1, and we also already settled for step 2. Then now we can proceed to step number 3, which is the delta H. So from here, we know that delta H is when 1 mole of water is formed. Okay, so we need to do the comparison. When 0.1 mole water is produced, the energy release is negative 5712 joule, or which is 5.712 kilojoule, because we already know that delta H always must be in the unit of kilojoule per mole. Then it will be better we convert it to kilojoule first, or you want to convert after that also, no problem. Then now they ask us to look for, if 1 mole of water produced, how much of the energy will be released. So you can use the crossover multiplication, which actually is end up negative 5.712 divided by 0.1. So will be equal to negative 57.12 kilojoule per mole. Question 7 also related with the enthalpy of the neutralization. This time we have NaOH and then we have HCl with the similar volume but different concentration, mixed in a coffee cup calorimeter. So and then the enthalpy of neutralization, which is delta H. Determine the changes of temperature. The question asks us to look for the delta T. Assume the calorimeter does not absorb the heat, so means that the heat only will be absorbed by the solution in this case. So again, we recall back, based on this step 1, we know that absorbed by solution, heat absorbed by solution. And then we're going to have 3 steps. Step number 1, we determine the Q. Step number 2, we need to find out the number of mole of water again, because it is about enthalpy of neutralization. Step number 3 is the delta H. Since delta H already give to us, so it's easy to settle, already settled. Second, we need to know number of mole of water first, then only we will able to proceed to step number 1. Okay, so like just now, we need to find out what is the number of mole of NaOH. This time, mole of NaOH will be different from HCl because even they have similar volume, but they have different concentration. So number of mole of the NaOH is mv over 1000 equal to 125 over 1000 equal to 0.0025, while number of mole of HCl is 2 times 25 over 1000, which is equal to 0.005 mole. This one also mole. Then now we need to write the chemical equation. 1 mole NaOH going to react with 1 mole HCl, produce 1 mole H2O and 1 mole NaCl aqueous. So based on here now, then this is 0.0025, this is 0.005 mole. So from here we know that NaOH is limiting reactants. Okay, the ratio here is 1 to 1, 1 to 1, and to the water also 1. Okay, so that's why here NaOH has a less number of mole, so means that this is limiting reactant. So if NaOH is limiting reactant, so means that we are going, if we want to know the number of mole of water produced, we have to compare mole of water with the NaOH. So end up we have this statement, number of mole of NaOH will equal to number of mole of H2O. Okay, then we will going to have next part at where we need to, because we consider we already settled for number of mole of water, so now we need to find out what is the value of the Q. So delta H is kilojoule per mole, so means that 1 mole of water produced will release 57.46 kilojoule. Then now we only have 0.0025 mole of water, 0.0025 mole of water. So how many more of what is the heat release? So we will use close our multiplication. We will get the Q value is 0.144 kilojoule. Next one, we are going to use the Q to determine the what we need to determine, the delta T. Okay, the change of the energy. So in the question here doesn't give us the heat capacity or specific heat capacity, but because of this one is the solution and then they didn't mention anything, so we will treat density solution. Maybe I need to change the color so that you know that. Okay, density solution, if not given in the question, always we treat it 1 gram per ml. And then the specific heat capacity for water, for solution, always equal with the water, 4.2 joule per gram per degree Celsius. Okay, so means that now here we are going to use Q equal to MC delta T. So we no need to put negative sign in this formula, is okay, because the negative sign only show the heat is released. So the mass again, previously we mixed 25 ml of NaOH with 25 ml of HCl. So the volume is 50, which the mass also equal to 50 gram. The specific heat capacity is 4.2. Delta T we have no idea, but because of here is in joule, so here is in kilojoule, so means that we have to convert to joule, which is basically is 144. So press the calculator, the delta T will equal to 0.69 degrees Celsius. Objective question number 1. An iron nail with the mass 4.5 gram cool from 45 to 25, which we know that the delta T is 20 degrees Celsius. How much heat is given off? The heat is Q in the cooling process, given the specific heat capacity, which is the small c. So from here, we know that when the small c is given, so we are going to use the formula mc delta T. So because this is specific heat capacity of iron, so the mass here must be referred to mass iron, which is 4.5 gram. Specific heat of iron is 0.45. Change of temperature is 20. Press the calculator, so we will get 40.5. So again, because the unit over here is gram, joule per gram per degree Celsius, 20 degrees Celsius. Celsius and per degree Celsius cancel out, per gram and gram cancel out, and out the unit is joule. So the answer is 40.5 joule. Question number 2. The specific heat capacity of water is 4.18 joule per gram per degree Celsius. This means when we want to increase 1 gram of water by 1 degree Celsius, this is the energy that required. But now the question wants us to determine the heat capacity for 120 gram, which is the heat capacity is the capital C. So basically this capital C is referred to MC. Okay, so the M given here now is specific heat capacity of water is 4.18. So that means here we need to refer mass of water, which is 100 gram. So we multiply, press the calculator, we will get 501.6 joule per degree Celsius. So 120 gram, and then this one is joule per gram per degree Celsius. Per gram and gram cancel out, so that's why the unit left joule and per degree Celsius. So the answer is donkey. Objective question 10. Which of the following is not true about simple calorimeter? As we know, simple calorimeter is made up like a coffee cup, a polystyrene cup. So always is used to determine enthalpy of neutralization. So it is also known as constant volume calorimeter. This is wrong. Constant volume calorimeter basically is referred to bomb calorimeter. Okay. It consisting a non-mass of water or solution in an isolated container. Yes, because when the neutralization happens, we know that amount of acid and base is added. So non-mass is correct. With a thermometer, help us to do the measure the change of the temperature, and then the stirrer is let the reaction occur. It is used to measure the amount of heat release in a non-combustion reaction. So just now already mentioned, simple calorimeter normally is used for neutralization. So statement 3 also correct. So incorrect statement in this question 10 is 1. So basically we already cover all the questions about calorimetry in the tutorial question. So thank you for spending time. So next subtopic is about the Hess law.